Alright, now we're in lesson 2. Let's take a look at problem number 3 from your homework tonight. They're asking us to find the equation of the normal line, so you recall from your notes and from class today that the derivative at a point is going to be equal to the slope of the tangent line. So that is the derivative. But if you're being asked to find the normal line, that's synonymous with perpendicular. So you just take the opposite reciprocal of the slope of the tangent line. So our job is pretty much going to be to always find the slope of the tangent line and then to write the equation for the appropriate line. So in this case, we're going to find the slope of the tangent, and then we're going to use its opposite reciprocal, and then find that value right there. So what pieces of information do we need if we're going to write an equation of a line? Well, we are going to need an x and a y coordinate, and we're going to need to know the slope. So we do have an x coordinate right now. We know that it's at -1. So before we get started, we can actually find the y value by using the original function. So if we're going to find the function value or the y value at a -1, we simply plug it in and evaluate it, and we get the y value is equal to a -2. Okay, so there we have our x and y coordinate, and we'll just put that over here in the corner. So we know we're going to put it into the form y equals mx plus b, and we have our y value is -2. Still trying to find the slope, and we have an x value of -1, and that will allow us to find our y-intercept once we find the slope. So just recall, maybe it's worth noting that we're going to find the opposite reciprocal of the tangent, because we're looking for the normal line. So we'll just kind of tuck this away over here in the corner, and we'll come back to that after we find the slope of the tangent line. Alright, let me erase all this stuff that we have. Whoops. Let me try to erase it. So let's set off on our quest to find that. So we're going to use the derivative formula, the limit definition, as x approaches -1, and our function is 2 over x minus 2 over -1 all over x minus a -1. So that simplifies to x plus 1, and this simplifies to 2 over x plus 2. So now we have to try to simplify the numerator so that we can get rid of this divide by 0 problem that we have working in the bottom right now. If we plug in a -1 right now, obviously we are going to have trouble. So you looking at the top, and they both of course have a 2 in common. So if you factor out a 2, you get that, right? We still can't simplify this, can we? Well, there's probably a couple things we could do here, but one thing we could do is we could go ahead and try to divide this fraction out. Well, how do you divide a fraction? multiply by its reciprocal, right? So the reciprocal of the bottom would be 1 over x plus 1. And we could distribute that 1 over x plus 1 to both terms and see if that helps us out any. Or we could try to find a common denominator in the first half of this equation. Either way, we have a little bit of work to do. So let's just go about that real quick. Let me see if I can get some more space here. Well, if we find a common denominator, the common denominator would be x, right? So we have 1 over x plus, well, let me erase this, over x all over 1 over x plus 1. And we still have our 2 out in front of there. So now, if you see what we just did, hopefully you can see that that's a 1 plus x, and that cancels with that 1 plus x. So the derivative is 2 over x. And remember, we are looking at this as we approach what? As we approach x at -1. So we have our value, and I don't know how to get this screen to get any bigger, so I'll try to squeeze everything in right now. So we're going to take this, let me highlight this in blue. We're going to take this, and that's going to be our slope of our tangent line. So we'll continue up here. Let me erase some of this stuff up here. And we have slope of the tangent line is equal to a -2. Well, remember, in this problem we aren't so interested in the tangent, we need to know the normal line, so we're going to just plug in, make this the opposite reciprocal. So we have the opposite of a -1/2, which is +1/2. Okay, so from there you can find the rest of the values you need, and you can rewrite the equation. Okay.